Hello friends, I welcome you all to my channel. This video is part of the playlist Maths 11 Limits. In this video, I will solve the problems of the given DPP sheet number 8. If you have not seen the previous video on how to find limits using the standard results for exponential and logarithmic functions, I highly recommend that you see the previous video. Uh, Before I get started, I will highly request all of you to support my channel by subscribing to my channel and like my videos, share the videos with your friends, and do not forget to press the bell icon so that you will be notified by my future videos, as I will be uploading more videos on limits for class 11 mathematics uh, very frequently. So stay tuned for my future videos and please support me. So let's get started with this video. Okay, so let's solve the problems. Problem 1 is uh, limit x tends to 0, 1 minus 3 to the power x minus 4 to the power x plus 12 to the power x divided by root over 2 cos x plus 7 minus 3. So clearly we can see the terms a to the power x in the numerator. We have three such terms, and also in the denominator we see irrational terms. So for sure we have to rationalize the denominator to get rid of the roots, and we try to since there are we try to see if we can mm, factorize the all the a to the power x terms and get yeah, so we get two terms of the form a to the power x minus 1. So uh, we can see that uh, minus 4 to the x the 12 we can write it as 4 to the power x into 3 to the power x, and let's rationalize this the numerator. So we multiply the conjugate term with both the numerator and the denominator for rationalization. Now the a to the power x terms, uh, we can clearly see uh, we can rewrite it as uh, now if we rationalize, if we multiply the numerator after rationalization, we get 2 cos 6 plus 7 minus 9. Now the a to the power x terms we can take 1 minus 2 to the power x common, and we get this, and we have uh, cos x plus 7 plus 3 and the numerator, if we take 2 common, we get minus 1. Now uh, uh, we would like to rearrange the terms so that we have the form a to the power x minus 1. So this, after rearranging, can be written as, and over here we have and 2 cos x minus 1, we know that 1 minus cos x, we take minus common and we write the cos x minus 1 as 1 minus cos x, and then we 1 minus cos x is 2 sine square x by 2. So 1 minus cos x is 2 sine square x by 2. Now we need x in the denominator for 3 to the power x minus 1 as well as 4 to the power x minus 1. So we will uh, so we bring x to both this term, and over here we have cos x plus 7 plus 3, and we have to adjust the 2x. We can do that. Okay, let's multiply the minus 2 and 2. We get minus 4, and that uh, uh, we need to have x square by 4 below sine square x by 2, so that we can apply the sin x by x standard result. So this we write now. And we also have to adjust this, and also these 2x we have to adjust by x square. So what it becomes, this x square by 2, this will become x square by 4. The 4 will go in the numerator, that will get cancelled with this minus 4. This x square will get cancelled with this x square. So eventually we will have a minus 1, and okay, let's just directly now, no, let's first write it down. Uh, 2 cos x plus 7 plus 3, and over here we have sin x by 2 square, and that is all. Now we can apply the standard results and substitute the value of x equals to 0 to this irrational term in the numerator, and we get minus 1 is there outside. For this we have log what was the standard result? Log 3. So we have what was the standard result? Log EA. Okay, so log E3, and we have log E4. Over here we will get 3 plus 3, 9, and this is 1 square. This becomes uh, mm, this becomes minus 9 log e 3 log e 4. 336, sorry, this will be 6, 3 plus 3 6, and this is 6, and we can further simplify as 2 log e 2, and this becomes minus 12 log e 3 and e 2. This is the answer. Okay, let's move to the next question. It says limit extends to 0, a to the power tan x minus a to the power sin x divided by tan x minus sin x. Now, for this kind of to solve this kind of problem, you can think of two approaches. Let me first write down the two approach. If you have a limit something like this, something like if you have say a to the power fx minus a to the power gx, and here some other function hx, where it must have where this is extending to c, some constant fx is 0, and a limit of x tending to c gx is also 0. Then what do we do is since the base is same, eventually we have to create a form a to the power x minus 1, and then a to the power fx minus 1 and divided by fx, that we have to create. So from the numerator, since the base is same, we can take a to the power gx common. Limit x tending to c, we take a to the power gx common, and this becomes a to the power fx minus gx minus 1, and this is hx. A to the power gx won't create any problem when we substitute x tending to c. Usually it won't create any problem. So now we see we have a to the power fx minus gx. So we need fx minus gx in the denominator, and what we do is we create that a to the power fx minus gx minus 1, we create that fx minus gx, there is no space, and there was hx, and we have to adjust fx minus gx, so multiply it with the with the numerator also. I'm writing it as a as a placeholder, where a is fx minus gx. So this part, a to the power fx minus gx minus 1 divided by fx minus gx, this whole part will be log a. Now we have to solve now so this limit becomes, after we have applied, we have log e a x tending to c a to the power gx a. We have to solve this. Hopefully this will be solvable. We have to solve this limit. This is the approach when the base is same. We see some two terms of the form a to the power x, base is same, but the x is different, some function of x. So if we apply this approach in this problem, we see that we will take a to the power sin x common, and this becomes and you see we already have the tan x minus x in the denominator. So uh, see, now when x tending to 0, tan x minus sin x is tending to 0. This is of the form, the general form I discussed in the previous video. The general form, this one, x tending to c a to the power fx minus 1 by fx. Fx is tending to where fx is tending to 0 when x tending to c. This is also the value is standard result we can apply is log ea. So fx, what is fx in this problem? Fx is in this problem is tan x minus sin x. So this this part will be log a, and if we substitute 0 a to the power sin x, it becomes 1. So the answer is this, which is log ea. So when we have a to the power x terms in the numerator, two terms where the base a is same but the x is some function, different function, we apply this approach. And if the base is different, base is different, and the a to the power x is same, some function of same, then we have to apply a different approach. We will see if we can apply that approach in some other problems here. Okay, let's continue with problem number 3. It says limit x tending to 2 sine of e to the power x minus 2 minus 1 divided by log of x minus 1. You see, we have a standard result log x tending to 0, log 1 plus x by x is 1. So over here also the term x minus 1 is also tending to 1 when x is tending to 2. So we have to create the form log of 1 plus x by x. Sine e to the power x, sine of e to the power x, and also see we have e to the power x minus 2, and this x minus 2 tends to 0 when x is tending to 2. So this whole thing sine of x, this x is here e to the power x minus 2 minus 1. Clearly we have to apply the sin x by x result, we will create this thing, and of course we have to multiply that to adjust it, and over here we are left with log of x minus 1. We will write it as 1 plus x minus 2. So we get the form log of 1 plus x. Instead of x, we have a function which is here x minus 2. So in the general form we discussed in the previous video, you will see that this one log a 1 plus fx by fx extending to c is log ae if fx tends to 0 when x tending to c. If a is e, then we have 1. So in our case, the base base of log is e. So this is definitely, if not, if no base is given, it is e. Now sine. So now you see sine of e to the power x minus 2 minus 1. This whole thing e to the power x minus 2 but minus 1 becomes 0. So we have the same term in the denominator. So we can apply the result sin x by x. See this thing will be 1 directly. Now we have to deal with this. To apply the standard result e to the power x minus 1, we will need the x minus 2 term. So let's create the x minus 2 so that this gets sorted out. We can apply standard result for this, which will be 1. We have to adjust x minus 2 above, and we have log over here 1 plus x minus 2. So this x minus 2 we can bring down downwards to as the denominator of log e, and it will have the standard result log 1 plus fx by fx, where fx is x minus 2. So now at this stage we can directly put the standard result. This becomes 1, this becomes 1, also this becomes 1. So the answer is 1. I hope it's clear. Over here, so I will just write it down so that you can relate. We have okay, one more thing I would like to say, that please note it down with reference to the previous video. This general form, we have this general form that for all the general forms, we are saying that a to the power fx minus 1 divided by fx is log e a, where x tends to c, where it must have limit of fx x tending to c equals to 0. Now this whole form, this whole form is normally in a compact form written in the textbook, or in a compact form is also written like this: limit fx tending to 0 a fx minus 1 fx is log e a. So whatever the limiting variable is in the given limit, for that limiting variable, if fx is tending to 0, that is how we write it below limit that fx is tending to 0. For whatever the limiting variable, if fx is tending to 0, then a to the power fx minus 1 divided by fx is log e a. The same compact form can also applies to all other general forms. It is too clumsy here, so I won't write it. Please note it down. This is the same. These two are the same. This is the compact form, and this is in a more detailed form. So over here, let me write the result I've used in the compact form, that fx tending to 0, we must know that fx by fx is 1. Also, limit fx tending to 0 a to the power fx minus 1 by fx is log e a. Also, limit fx tending to 0 log 1 plus fx by fx is 1 so that you can relate. Okay, let's do problem number 4. It says limit x tending to 0 e to the power x minus e to the power x cos x divided by x plus sin x. So again here in this problem we see two terms of the form a to the power x. So a is same, the base is same, but the x, the function of x are different. In the first term it is x, in the second term it is x cos x. So we would like to take the second term as common, and we get x minus x cos x minus 1. It is important to check that when we are applying this method, this function, the power x, the function of fx, this must tend to 0 at the given tending value of x. So at x tending to 0, this is definitely 0. Now the, the first thing we must do is complete the form of the standard result. So this is, if we take basically this is x, we could take common 1 minus cos x. This is 1. We want to have this in the denominator of this. So x 1 minus cos x, and we already have x plus x plus sin x, and we also have to multiply here to adjust this 1 minus cos x. What else? So okay, so e to the power x minus 1 by, then we have we can bring the x down, this x down downwards to the numerator as the bring down as the denominator of this thing. We can bring the x down. Okay, now so it becomes e to the power x cos x. We have the standard form minus 1 1 minus cos x, and this becomes 1 plus sin x by x. Now we got two standard results, this one and sin x by x. Sin x by x at x tending to 0 will be 1, this will be 2, no problem. This whole thing will be 1, no problem. This is no problem. But if we substitute x equals to 0, this thing 1 minus cos x becomes 0. So the answer will be e to the power 0 over here, 1 for this, and 1 minus 1 for this, and 1 plus 1 for this. This becomes obviously uh, 0 because of 1 minus 1. So 0 is the answer. Okay, let's do problem number 5. If you have any problem, if you are facing any problem in following my solution or any videos, I will highly request you to let me know in the comment section so that I can address your issue or problem. Because until and unless you do not let me know your issue or problem, I won't be able to help you out. So let's do problem number 5. X tending to 1, a to the power x minus 1 minus 1 sine pi x. So the general approach will always be to create the standard form. As we know that x minus 1 is tending to 0 as x tending to 1. So we have this, and we would like to have x minus 1 in the denominator, and we will adjust this. And for sine pi by x, we will also like to have pi by x and adjust the pi x, because pi x extending to 0 will become 0. We also put pi x the denominator, so this whole thing will be 1, and we adjusted pi x by multiplying by with pi x. And now what we can do is it's equals to 0. This is pi x. We have now pi x. This is fine. This will become log a. This will become 1. We are left with this one and this one. X minus 1 by x. How do we solve this? I hope a to the power x minus 1, to the power x minus 1. We have, oh, this is 1. Sorry, this is 1, not 0. This is 1. Okay. If this is x minus 1 pi x, one by pi minus this whole thing becomes log EA into no, we have to first simplify. We have this. We have we have to simplify x minus 1 by pi x. What it becomes? 1 by pi minus, something is wrong. This is becoming 0. It should not be 0. A to the power x minus 1 divided by sine pi x. Okay. So over here, this pi x is not actually becoming 0, it is becoming pi. It is becoming pi. So we have to do a little bit of change of variable for simplification. We cannot apply the sin x by x because pi x is becoming pi. It is not becoming 0. So we know the standard results, sin x, limit of x sin x by x, x tending to 0 is 1. But over here we have pi x. When x tending to 1, it will be sin pi. It is not becoming sin 0. So uh, let over here, if we just do x minus 1 as t, implies t tending to 0 as x tending to 1. So the limit becomes t tending to 0, a to the power t minus 1 t. This becomes t uh, and let's not do this. Let's keep it the same. Pi x. So we have sine pi 1 plus t now sine of pi plus pi t sine of pi plus pi t pi plus pi t. The quadrant of this angle is in the third quadrant, and it will be negative. So this, okay, so sine pi plus pi t becomes minus by t. Now this is t by, we have minus pi t. Now it's fine, we can use the sin x by x limiting result. What we do is we add the pi t over here and multiply with pi t. So the t will get cancelled. Now if we put the standard result, we get this minus we have and log e a, and we will left with this pi 1 by pi. So this becomes minus log a by pi is the answer. Okay, let's see problem number 6. It says limit x tending to 0, 10 to the power x minus 2 to the power x minus 5 to the power plus 1 divided by x 10x. So clearly we can see we can factorize the numerator to get two terms of the form a to the power x minus 1. This 10 we can write as 2 to the power x into 5 to the power x now we take 2 to the power x common, we have this and we have this So, okay, now after rearranging, after doing the factorization in the numerator, we get this x tan x. Now, we would like to have x for 1 for 2 to the power x minus 1 and 1 for 5 to the power x minus 1, so that we can apply the standard result a to the power x minus 1 by x. So 1x for this one, 1x for this one, we have x square. We have to adjust this with x square. Now, so this becomes now 1x gets cancelled from this x tan x x, and this becomes x by tan x. Now you know that you know that limit extending to, we also know that sin x by x equals to 1, also x by tan x is 1. Now, if we apply the standard result, we get log e 2, log e 5, and 1. So, the answer is log e 2 and multiplied by log e 4. This is the answer. Okay. Now, let's see problem number 7. Problem number 7 says x limit x tending to pi by 2, 2 to the power minus cos x minus 1 divided by x into x minus pi by 2. Okay. So, 2 to the power minus cos x. Minus cos x will be 0 when x tending to pi by 2. So, first we try to complete the form of the standard result. We have this thing, and we would like to have the same to the power minus cos x, this thing in the denominator. So we have the standard result over here, because here x a to the power x minus 1 by x, here x is a function of x which is minus cos x, which tends to 0 when x tends to pi by 2. Now we have to adjust this minus cos x, and we are left with x into x minus pi by 2. Hmm. Hmm. Okay, now it's better to whenever there is trigonometric expressions, this is sorted out, but we are left with this. We have trigonometric expressions where the x is the tending variable is not tending to 0, it is tending to something else. So it's better to change the variable so that the variable to a new variable which will tend to 0. So this thing will definitely be log 2. So we can directly, without any problem, we can say that this is log 2. We can bring it out and solve this thing. Let's also bring the minus out. We have to now solve this thing. this thing. So over here, let x minus pi by 2 equals to t. T. This implies t tends to 0 as x tends to pi by 2. Now the limit becomes uh, limit t tending to 0 cos of pi by 2 plus t, and this is t, and pi by 2 plus t. Now minus this is what is cos pi by 2 plus t? Uh, Pi by 2 plus t, angle is in the second quadrant, and okay, this will be minus uh, t, and we have the t in the denominator. We can merge that, club that with the sine t by t, and we are left with 1 by pi by 2 plus t. So this becomes, now if we put the standard result, sine t by t will become 1, and we put the value t as 0 in this expression, it becomes uh, pi by 2. So this becomes 2 goes in the numerator, pi remains in the denominator, and it becomes 2 log e2 by pi is the answer. Okay, so let's see the next problem. It says limit x tending to 0 e to the power 3 plus x minus sin x minus e to the power 3 and x. Okay, so we see two terms of the form a to the power x with the same base e, and what if uh, so x tending to, if we club, if we take e to the power 3 common, we can write e to the power x minus 1 and this thing. So we are getting a good form. If we split into two terms, we will have uh, limit so now we can put the standard result, and we get so the answer is e to the power 3 minus 1. Let's see the next problem. Uh, limit x tending x x tending to 0 log of a plus x minus a minus x divided by x. Now, for this form of question, uh, definitely we can see that we can create the form log 1 plus x by x, but over here we have log a plus x and a minus x. So a good idea will be to uh, take a common over here and we write it as this, and this is, we take a common this by this. Now applying log AB equals log A plus log B, we see this becomes log A plus log 1 plus x by A minus log A minus log 1 minus x by A divided by x. Log A gets cancelled, and we have we can split these two terms and we get by this, and we have log 1 minus x by A by x. Now, to create the general form, we know that log of 1 plus fx by fx when fx tending to 0 is 1, but in the denominator we have a. So we create the x by a, we create the x by a and adjust the a. Over here, what we do is we can write it as 1 plus minus x by a, and we must have the same minus x by a and adjust minus a. Now we can bring the constant out and have minus minus plus minus 1 by a we are getting the standard form where log of 1 plus fx by fx when fx tending to 0 is 1, where fx over here is minus x by a, which is tending to 0 when x tending to 0. Over here, the fx is x by a. Now we can did I do any mistake with the minus and plus? Let me check. And this is minus 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 x by a. This is, we split it, base minus 1, okay, and okay, so this minus a will get cancelled with this minus and will become plus over here. So now this limit is 1 and this limit is 1, so we get 1 by a plus 1 by a, which is 2 by a is the answer. Let's see the next problem. 10 says limit x tending to 2, 3 to the power x plus 3 to the power 3 minus x minus 12 divided by 3 to the power 3 minus x minus 3 x by 2. Okay. Mm, hmm, hmm, hmm. Let's simplify it and see what it becomes. This is 3 to the power 3 uh, hmm, uh, hmm, extending to 2 to 1 to 1. What we can do now is um, minus 2 6 to 2 minus 2. This is x by 2. Hmm. This becomes limit x tending to 2 3 2x plus 3 cube minus 12 4 3 4 3 6 this is 6 divided by we have 3 to the power 3 minus 3 to the power 3x by 2. Ah, 9 to the power x. So this is 3 to the power 2x is 3 to the power 3 square whole to the power x. So we have here 9 to the power x plus 3 to the power 3, and we can split the 12 minus 3 minus 9 minus 3. And over here, if we take 3 to the power 3 common, we get 1 minus 1 minus what will be this? 1 minus 3x by 2 minus 3. Hmm. Uh, should it be? How is it helping? 3 to the power 3 x minus 12. Minus 3 minus 9 minus 1 minus 3 minus 9. Hmm. Uh, minus 9 minus. Aha, this will be 3 to the power x. So, this will be 3 to the power x. Um, 6, 6. Clearly, we have to factorize it. We will have factors. Minus 9, 3 to the power x plus 3, 3 minus 6. And write it as minus 1 minus 3. Will it help anything? Uh, over from this, we 3 to the power x minus 3, we club it, and 3 to the power 3 minus x minus 9. If we take 3 common here, we get 3 to the power x minus 1 plus if we take 9 common here, we get 3 to the power uh, mm, 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 mm. 3 minus 6 minus 2. Mm, 3 common 1 minus x 1 minus oh, okay, so this is basically uh, minus 3, this is 3 minus 9. If I take 9 common, I will get 3 to the power 3 minus x by 9 square minus 2. So this is 3 to the power x minus 1 minus 1 plus 9. This thing is 3 to the power 1 minus x. To the power 1 minus x minus 1 minus 3 to the power x by 2. What we can do, okay, So we can bring x down here, and we can bring x down numerator, and okay. So I will cancel all this. It's a bit complicated. Nothing. I mean, as such, complicated. Just to deal with the powers properly, carefully. So now, so this is limit. I've already done the work. So this thing is equal to this. So I will directly write this uh, 3 to the power 3 x minus 1 plus 9 to the power 1 minus x. But 1 minus x, it will not help. This 3 to the power x tending to 2. Okay. X tending to 2. This is 1. Mm, 2. This is 9. 2. 12. Mm, mm. X minus 1 to the power x. I think it's better if we change the variable to something t tending to 0. Uh, Let's see what it becomes. Let x let x equals to 2 plus t. This implies we want the tending variable to be 0. This implies t tending to 0 as x tending to 2. So the limit becomes t tending to 0 3 to the power 3 to the power 2 plus t plus 3 to the power 3 minus 2 plus t minus 12. Mm, then 2 to the power 3 minus 2 plus t minus 2 to the power uh, x by 2, that is 1 plus t by 2. One minus t. Mm, mm, we can rewrite this as 9 into this, and this becomes 3 to the power 1 minus t, which is basically 3 by okay, so 3 minus t and we have minus 12 minus 12 divided by this is 3 to the power 1 minus t, which is 3 to the power 1 minus t minus we have we have 3 to the power 1 plus t by 2 minus 3, basically this is root over 3 to the power t. Should when t tending to 0 when t tending to 0, what is 3 to the power t? If we substitute t tending to 0 implies 3 to the power t tending to 3 is greater than 1. This should be tending to 0. So if we again make change of variable, let 3 to the power t equals to z. This implies z tending to 0 as t tending to 0, we get 9z plus 3 by z minus 12, 3 by z minus 3 root z. Root z. That's 3 9z square minus, okay, we can cancel out the 3 common from both the numerator and the denominator, and we get 3z plus 1 by z minus 4 1 by z minus root z. 3z square minus 4z plus 1. Okay, so if we simplify this becomes 3z square minus 4z plus 1, and this becomes 1 minus z to root z. If we factorize the numerator, we get 3 3z z minus 1. So But this is not helping anyway. One minus z. The denominator becomes 1 if we substitute z, and this is becoming one. 10 minus 4 by 3. No. Let's see the problem again. 3 to the power x plus 3 to the power 3 minus x minus 12. 3 to the power 3 minus x minus x by 2. We will have over 27 by 3 to the power x. 27 by 3 to the power x by 2. We have taken x equals to 2 plus t. Okay, then t tending to 0 as x tending to 2. Okay, if we substitute x equals to 2 plus t, it becomes 2 plus t plus minus 2 plus t minus 12 divided by 3 to the power 3 minus 2 plus t minus 3 to the power x by 2, meaning 1 plus t by 2. This becomes 9 into 3 to the power t plus 1 minus t. 3 into 1 minus t minus 9 minus 3 minus 9 minus 3 over here we can write it minus 3 minus 9 minus 9 minus 3 over t minus 1. I don't think we will need this. Change of variable again. Three into 1 minus t power minus 3 to the power 1 minus t. 3 into this is 3. 3 into 3 into 3 to the power t by 2. So this is fine. Now we will write minus 12 as minus 9 minus 3, and from we take 9 common, 3 to the power t minus 1, and from here 3 common, minus t minus 1 and mm, mm, oh no, this will be, yeah, okay, and we will have mm, 3 minus 3. What if we split the two terms and and we bring a t over here, adjust the t, and we get the t this is 3 with the 3 common, minus t and minus 3 t by 2. Okay, and also we have this term, this uh, t tending to 0, 3 3 to the minus t. What if we put the minus t over here, adjust t, and we have 3 hmm, this thing, this limit, this thing, 3 to the power t minus 1 by t will become 1. Also over here, 3 to the power minus t minus 1 divided by minus t will become 1. So we can directly put the will become log 3, will become log 3. So then we will have to deal with this limit, this limit. So this is, let me say this term, this limit term has a and this has b, and individually try to solve a and b, then we will, the final result will be a plus b. So a is limit t tending to 0, 9 by t. This is t by uh, what if okay, what if we take 3 to the power t by 2 common out? 3 to the power t by 2 common, since we are I earlier discussed, if we have two terms, a to the power x minus a to the power x, where the base is same but the power x is different but a function of x, we take common and this becomes we are taking 3 to the power t by 2 common from here. So this becomes minus t minus t by 2 minus 1 minus 1, and these 3 by 3 by t by 2 will not create a problem because it will be 1 when we will substitute t equals to 0. These three it cancelled, not cancelled, but this becomes 3. We have this, rather we have this and then let's have this won't create any problem. Now this we have t by, this becomes 3 to the power minus 3 by 2 minus 1. So will we want to create minus 3 by 2 same in the numerator, then we can apply the standard result. So 0, 3, let's so minus 3 by 2 over here we have to multiply with minus 2 by 3 so now we can apply the direct result and we get uh, I hope you are following the solution. This thing, this whole thing is minus 3 by 3t by 2 divided by 3 to the power minus 3t by 2 minus 1. This follows the standard result, a to the power x minus 1 by x, x tending to 0. In fact, it follows the standard form a to the power fx minus 1 divided by fx, fx tending to 0. So this will become log 3. This is minus 2 by 3. This is 3 to the power 0, which will become 1. Log 3 gets cancelled. So we get minus 2. We get minus 2. Okay, let's proceed with B. What is B? B is 3 to the power t tending to 0, 3 to the power minus t. Okay, okay. So let's rub this together. Minus t and minus t divided by, we have 3. Okay, these 3 get cancelled, so we did not write this 3. We will have 3 to the power minus 3, 3 to the power minus t minus 3 to the power t by 2. We will do the same thing. Okay, So this is we will take 3 to the power t by 2 common. This becomes minus t minus t by 2 minus 1. This is 0, 3 to minus t minus 1 by minus t. Uh, this won't create any problem, and this is by 3 to the power minus 3 2 by 3t by 2 minus 1. We would like to have minus 3 by 2 over here. So now we have to adjust 2 by 3, not minus 2 by 3, but 2 by 3, because we already have a minus t over here. So now if we now put this minus 3t by 2 divided by 3 to the power minus 3t by 2 minus 1 will become log 3. Now this will also become log 3, log e 3 into 1 by 3 to the power 0. Over here we have 2 by 3, and this becomes log e 3. log log 3 gets cancelled, and this becomes 2 by 3. And okay, so the answer is equals to a plus b, which is minus 2, a plus b, which is minus 2 plus 2 by 3. This is how much is this? Minus 6 minus 4 by 3 is the answer. So yeah, it was the main trick was to get this limit until from this point we had to split minus 12 as minus 3 and minus 9 minus 3, and then we got these two after taking common. We got two terms, a to the power x minus 1, and we had to adjust by putting t in the denominator. We splitted the two terms, and yeah, you can see the solution. It's just to create a standard result by adding new terms and then adjusting the terms, and the rest, in the most of the cases, the rest follows. So okay, this was problem number 10. Let's do problem number 11. Okay, so problem number 11 says limit x tending to 0 to the power 3x minus 3 to the power x divided by sine x. Okay, this was an example where I was discussing earlier. If when you have something like a to the power fx, when you have see, we can clearly a to the power fx minus b to the power gx, something like this, and whatever some other function. The general strategy is sorry, this will also be okay. this will be also fx when we have something like this. A to the power of x minus b to the power of x base is different. What we do is again we take this b to the power of x as common. And this will become a by b to the power fx minus 1 by hx. This b to the power of x won't create any problem. So we have now the constant a to the power of x, where a is actually a by b. So this is the way we simplify. So this is x tending to 0. This is 8 to the power x minus 3 to the power x sine 3x. We take 3 to the power x common from the numerator and we get 8 by 3 x minus 1 divided by sine 3x. I hope I did it right. Then you divide 8 to the power x by 8 to the power x by 3 to the power x. Yeah, 8 by 3 to the power x. Now we have to create the standard form. 8 by 3 minus 1, we have to have the x. We have to adjust x, this, and sine 3x. Now we would like to have 3x below sine 3x. So we already have x. We will multiply 3 and adjust the 3 by 1 by 3. So this becomes 1 by 3 and sine 3x by 3x. Now we can apply the standard result and we get 3 to the power 0 into log e 8 by 3 1 by 3 into 1 by 1. This is log e 8 by 3. Okay, we can, okay, the answer given is like this. So we are applying the formula. Log of a by b is log of a minus log b, and this is, if we write it as 2 to the power 3, the power comes in the front. This we have log 11. 1 by 3. Oh, sorry, this is 1. We have the 1 by 3 over here. 1 by 3. So 1 by 3, 1 by 3, and this becomes log e 2 minus 1 by 3 log e 3 is the answer. Okay, the final problem. Limit x tending to 0 e to the power x plus e to the power minus x minus 2 divided by x's square. So clearly we can see that e to the power x plus e to the power minus x minus 2. minus e to the power x e to the power 2x minus plus 1. Let's try to simplify this. E to the power x, if I write e to the power minus x as 1 by e to the power x and simplify, we get e to the power 2x plus 1 minus e to the power x. Now the numerator is e to the power 1 by e to the power x. So e to the power 2x plus 1 minus e to the power x. This numerator is actually e to the power x whole square plus 1 square minus e this x square. So this is e to the power x minus 1 whole square. Okay, so we can write it as e to the power x minus 1 x whole square. If we apply the standard result, this becomes 1 square. This is 1. This is the answer. Okay, that was all. Once again, if you are following my videos and these videos are helping you to learn something, to learn about limits, and please let me know if you have any kind of difficulties in solving limits, or if you have any kind of suggestions for me to do. I will definitely try that. So please let me know your feedback in the comment section. What else do you need? Even though limit is not complete, I still have to do trigonometric functions and the limits where the expansion series will be used. Please let me know your thoughts. If you have any special kind of, if you need any any specific thing to discuss on limits, I will definitely try my best. Thanks for watching, and until the next video, take care and bye.